Hello, in this video I'm just going to be showing you how to differentiate by rule. So we're looking at a couple of different equations here and I'm going to show you how you can differentiate these. And then after I'm finished that, I'm going to go to some practical examples of how we could use this to find slopes of points and find equations of lines and things like that. So quickly, first of all, I'll just take a function like this, f of x is equal to, we'll just take this first example here, 4x squared minus 6x plus 3. Now, how you differentiate this by rule is you take the power of any, if there's a power over any of the x's, you take it and you multiply it by the number in front of the x. So that's the first step. So we'll just write that down. And when you're differentiating, there's two different ways we're going to write it. Will be either dy dx, which I'll show in a minute when we're differentiating y, or for this case here, you're just going to put a little dash after the x. So this means we're doing our differentiated function. So number one, take that 2, multiply it by the 4. So whatever the power is, you'll get 8. And then take whatever the power is and reduce it by 1. So I'm going to put 8x, and then I'm going to reduce that by 1. So if I take 2, take away 1, it's going to give me 1. Then if we do the same for this one, well, this is x. Normally you don't write it, but it is x to the power of 1. So in this case, it's going to be 1 multiplied by minus 6. And then that is going to turn into an x to the power of 0. And you won't always write this out, but I'll just write it in this time. So you can see this is x to the power of 0. And then 3, if there's a constant at the end, all you have to do is just remember to get rid of it. And I'll actually show you why that is. I'm going to just put an x beside that and put a 0 on it. So if you think about that x, anything to the power of 0, 3 to the power of 0, 5 to the power of 0, a million to the power of 0, it's always equal to 1. So in this case, you've got 3 by x to the power of 1. So we'll actually follow that rule for this one as well. So you multiply the 3 by a 0, and if you multiply anything by 0, you're just going to get 0. So that's plus 0. And then it doesn't matter, even if you do take that x, you reduce it by 1, it doesn't matter because it's getting multiplied by 0 anyways. Now, you won't always write out these steps at all. And in fact, you'll never write out these steps, but I'm just showing you where it comes from just for this first example. So then when we want to finish that off, it's going to be 8x. We don't normally put in that 1 there, minus 6. And remember, x to the power of 0 is just 1, so you just get 8x minus 6 as your answer. So we take B. I'm going to do it without any of the steps that I've shown in the last one. We're just going to do it straight out like you would do it if you're doing it in an exam or anything. So G dash of x, so that's the differential, is equal to take the 3, multiply it by 5. So you're going to get 3 by 5, that's going to give you 15. Then you're going to reduce the power by 1, so 3 take away 1 is going to be x squared. So you're just taking the 3, taking 1 off it. The next one, we're going to take 2, multiply it by minus 4. So in this case, you're going to get minus 8, and then it's just going to be x to the power of 1. We leave out the 1 there. Then your final one is 6x. And now, if you can just remember this, if there's no power in the x, you can literally just drop the x. I know last time I did x to the power of 1 and reduced it to 0, but there's no need to do that step. So plus 6. And then if there's a constant at the end, all you have to do is just remember just to make that constant disappear. You just take that out altogether. So we'll try question C. So for this question, there's actually a little bit of rearranging we have to do before we differentiate it. So first of all, there's a y there. Don't worry about that. That's the exact same as there being a function sign in front of it. So y and function are the same thing. So what we're going to do is just rearrange this slightly so it's easier to differentiate. So we leave this one as it is. And then what we do is we leave the 3 there, and x squared is the exact, or the square root of x is the exact same as x to the power of a half. So we're going to put it like that because it's easier to follow our rule than when differentiating it. So our next line then, because we've got a y here, a differential can also be written like this, dy dx. So the difference in y with respect to x. So what we're going to do is follow the same rule. So multiply 3 by the number in front. So 3 by 1 is going to give you 3. And then you're going to get x. And then reduce that by 1. So 3 minus 1 is going to give you 2. And now we do the same thing with this. And this is why we converted it into this power form. So you're going to take a half and you're going to multiply it by minus 3. So minus 3. And I'll just write it out the long way first. So minus 3, and we'll just put in brackets here a half. We can put these together now in a second. And then we reduce this by 1. So we're going to get x by a minus a half. Because if you were on a half, and you take away 1, you're going to get minus a half. So we're going to tidy that a little bit further up here now. So for this one, we can just leave it as it is. This is just 3x squared. Minus, this is just going to end up 3 over 2. We'll actually tidy it up a little bit further after this as well. By x to the power of minus a half. So just on a side note here, if you had something, say if you had x to the power of minus 3, that's the exact same as if you write 1 over x to the power of 3. Or just to do one more example, if you had 2x to the power of minus 4, well, you could change that. That would be also equal to, so that would be equal to 2 multiplied by 1 over x to the power of 4, and then you can see you can put the two of them fractions together. So that'll be just 2 over 2 by 1 here at the top, x to the power of 4. So we'll use that to complete this question here. We're going to get 3x squared, leave that as it is, minus, so this one here will be minus a half. So we could put minus 3 over 2 multiplied by, then we're going to change this into 1 over x to the power of a half. And we can tidy that up further still. So we'll go on to our next line. 3x squared stays where it is. And then we're going to multiply 3 by 1. That's going to give us 3 on top. And then 2 by x to the power of half. And you saw when we were changing things at the very start, we actually changed this from a square root into this, into the power of a half. So we're actually going to change it back into our square root there again. So we're going to get that equal to 3x squared minus 3 over 2. And we're going to change x to the power of half just to the square root of x. So for question D, again, we're going to have a little bit more tidying up to do here. So you're going to take this without differentiating it first, leave that one as it is, because that's fine. We can differentiate that, and then plus, and then we're going to change this to x to the power of minus 4. So 1 over x to the power of anything is just that x to minus that power. So now we can differentiate it. So we're going to say dy dx to show it's differentiated, and then multiply 5 by 4, you're going to get 20. Then reduce the power by 5, so 5 minus 1 is going to give us 4, and then plus, and we're going to do the same, well, we'll actually do the same thing here. So minus 4 by plus 1 is going to give us minus 4x. Now, if you subtract 1 from minus 4, you're actually going to get minus 5. And then just before we finish up, we'll tidy this up and just put it into how we had our original example there. So we're going to get 20 x to the power of 4 minus 4. And then we're going to put in brackets here. Now, you don't have to do this step. I'm just doing this to show you how it's done, but you could do this in one line if you want it. So you're going to get 1 over x to the power of 5. So we're going to put that down then as 20 x to the power of 4 minus, and then just multiply 4 by 1, 4 over x to the power of 5. So this the last one here, e, we're going to take f of x, and we're just going to do some rearranging on it. So f of x is equal to, leave this as it is, and what we're going to do is just take that 4 out, so you're going to get minus 4, and then we're going to convert that, what's left over, the 1 over, this left over will be just 1 over x to the power of 3, so we're going to convert that into x to the power of minus 3. Now we can differentiate it, put our dash in there to show that it's a differential, and then we're going to multiply 3 by 3, gives us 9, x, reduce the power by 1, we're going to get 2, and then minus 3 by minus is going to give you plus 3. Sorry, my mistake there, and we forgot to multiply by 4, so it's going to be plus 12 x, and then reduce this by 1, subtract 1 from minus 3, and you're going to get minus 4. And then we can just tidy it up to just put it like we had our original equation there. So I'm going to say that's going to be equal to 9x squared plus, this time it's going to be 12 is going to be over on top, and then x to the power of 4. Now we'll go on to our next slide and we'll look at a few practical examples of where we could use these then. So for this next question, it's going to be find the slope and hence the equation of the tangent to the curve f of x is equal to 3x squared minus 3x plus 5 at the point where x is equal to 1. So I'll actually just pop in a quick picture of what that curve looks like. So you can see I've actually just got a picture that I did up on the site GeoGebra there of this curve that we're doing here. So that's what this represents. And just a small side note, if you've got a curve that has a positive, so you can see that, if you've got something that is a quadratic equation, so it has an x squared at the start, and it's got a plus before that, that's a curve that's going to be going up and down like this. And if you think about positive at the start, is going to be like a smiley face, so it's kind of happy and positive. If you had a negative in front of that front part there, it'll actually be a downward facing slope. That's just a useful fact to know. So what we're going to do is find the slope and hence the equation of the tangent to the curve at the point where x is equal to 1. So just mark that point out, but we're actually going to go through how would you find all of that in the equation. So we can actually see that's the point 1 and 5 from this dot here, and then if I just draw my tangent through it, it's this straight line, and we're just trying to find the equation of this tangent that's just sitting up by the curve. So first of all, we're going to have to find the point that's on it, and then we're also going to have to find what's the slope. So once we get a point on the curve and we get the slope, we'll be able to find the equation at that line. So the first one, to get the slope at that point, we take actually, I'll tell you what, we'll find the point first. So we know that we're looking for the point x is equal to 1. So if you want to find what's the y value of that, all you do is you just sub your 1 into that. So we get 3 times 1 squared minus 3 times 1 plus 5. And that works out then as 3 minus 3 plus 5. Which gives us 5, which we can see from our diagram anyways, but it is important that we need to know how to work that out. So we get y is equal to 5, and that is going to give us our point here, which is going to be 1 and 5. Now the next thing we're going to do is going to take this equation, and I'll just remove this part here, and we're going to differentiate it so that we can find the slope of it at that point. So we're going to differentiate it first, multiply the power by the number, so you're going to get 6x minus, get rid of the x here, so you're going to get minus 3, and then the 5 disappears because it's a constant. So that's our equation, our general equation for the slope at any point. So all we need to do is just key our point into that. So we take our x value, which is 1, key it into here, you're going to get 6 times 1 minus 3, and that's going to give us a slope of 3. So we're going to know here that our slope at this point is 3. Next, we're going to use our formula, which we've put down here for our general equation of the line. So we have our points, and this one will be x1, and this is y1, and we're just going to sub them into this formula. So you're going to take y minus y1, so you can see in that case it's 5, is equal to n, which we have as 3, and then x minus x1. So x minus, and then you can see x1 here as 1. So we're just going to tidy that up a bit. We can see y, we'll leave y on this side, is equal to, and plus we'll multiply this out. So 3x is going to be 3x. 3 by minus 1 is minus 3. And we're moving our 5 over onto this side. So when it's a minus here, it's going to become a positive. So we're going to get plus 5. And then we're going to get y is equal to 3x. And 5 minus 3 is plus 2. And just a quick reminder as well, you might have looked at before, the way you could find the slope here would be y is equal to mx plus c. And you can see m is equal to 3, our slope, which we had earlier on anyways. So for this question 8, we're going to be finding at what point on the curve fx is equal to 2x squared minus 4x plus 2 is the slope equal to 1. So what we're going to do is differentiate this, make it equal to 1, because we know it's the general equation of our slope, and then we're going to solve for x. So just so you can get a quick visual example, so if we think a line, first of all, that has a slope of 1 actually is just at 45 degrees, and the reason for that is you've got a rise over run that are completely even. So they're going to, as a fraction, going to be equal to 1. So you're going to have 1 there, or even if you had 2 there and 2 there, it'll always equal to 1, because that'll be the fraction. 1 over 1 is equal to 1, which is the slope. Note as well, it's a positive slope. If it was going down like this, it would have a negative slope. So if you can think about this, I can actually take this line, drag it straight down. It's going to be somewhere around there. We're going to expect it. So we can see that's the graph of our curve. So you can see it's somewhere just above 1, but we need to actually find that mathematically, how you get that. So first things first, we differentiate this equation. So take f dash of x, and that's equal to 4x. So multiply 2 by 2, 4, reduce the power by 1, it'll be 1 minus 4, drop the x there, and then the 2 disappears. So the next thing we're going to do is the slope of that is equal to 1. So all you need to think, this is the general equation for the slope. So you have 4x minus 4 is equal to, and then we just put in 1 here. So we solve that. So you get 4x is equal to 1. Move the minus 4 over, it becomes a plus 4. So you're going to get 4x is equal to, sorry, my mistake there, I put a 5, it should be 4. So 4x is equal to 5, and then you're going to get x is equal to divide both sides by 4. So 4 into this goes once, 4 into this, you get 5 over 4. So that's the x value, but it's actually said here, at what point on the curve fx is equal to 2x squared minus 4x plus 2. So we actually want to find what's the y value of that as well. So to find that we have our x value, we need to sub that back into our equation. So we'll write out the equation here, and we'll just sub in 5 over 4 to find our y value. Now, you can do this out in your calculator, and in fact, it'd probably be a good idea to do it out in your calculator, but just for the sake of it here, I'm going to go through it, manually. So 2, and you're going to take 5 over 4, square that, minus 4, and then we're going to take 5 over 4, plus 2. So you can just type that to your calculator, or you could do it out like following. So 2, and then you're going to square that fraction. So 5, you square the top and the bottom of the fraction, you're going to get 25 over 16, minus, you're going to multiply 5 by 4, you're going to get 20, divided by 4, plus 2. Let's tidy it up a bit. So we're going to take this, it'll become 50. 2 by 25 gives you 50 over 16 minus 4 into 20 is going to go 5 times plus 2. So you're going to get 50 over 16 minus 3. And then we're just going to change this into a fraction that has 16 below it. So what we'll do is we'll just multiply this one here. So just multiply it by 16 over 16, which is the same as multiplying it as by 1. So you're going to get 50 over 16 minus, and then 3 multiplied by 16 is 48. So you get 48 over 16. You can see when you go on to your next one, you just put them both over 16. And then you get 50 minus 48. And this is all equal to 2 over 16, which is equal to 1 over 8 if you divide the top and the bottom by 2. But again, it will be quicker to do out in your calculator. It's just, I did that just for... sometimes it's good to know this stuff if you need to add things with x's and stuff with them as fractions. You might be able to do that in your calculator. So we can just put our point over here. We're going to just drag that picture out again. So we have 5 over 4 and 1 over 8. And that's the answer of our point. So 5 over 4 and then 1 over 8 for our y value. So for our final question, at what point of the curve f of x is equal to 3x squared minus 12x plus 6 is the slope equal to 0? Is this a maximum or a minimum point? Now with this particular one, you'll be able to tell if it's a maximum or a minimum, and I'll show you why. This is a quadratic equation. That means it is a parabola. And then I said this earlier on, if it's got a plus in front of it, it's going to be going up like this. So it's going to have a positive value. If you think about a smiley face, you're feeling positive when you're smiling. And then if it's down like this, it's going to have a negative in front of it. So this is just for quadratic equations. Now you can get curves of all sorts, all different types. So you could have, say you could have curves like, if you had a curve like this, you could have several maximum or minimum points on it. So you could have a point here and you have a point here. And these are all points, and this is what's important to note. These are all points where your slope is going to be equal to 0. So if you put a tangent along this part here, if you put a tangent along here, if you put a tangent along here, all of these points are going to be equal to 0. But for this particular one, and we will need other methods to find whether they're maximum or minimum points on this one. But for this particular question, so you can see I've actually just put in the drawing from GeoGebra there. So you can see we're going to be basically looking for this line here. So you can see straight away at the last part it asks, is this a maximum or minimum point? So we've kind of answered that already. So if you understand that about a parabola, you'll know that. But again, there'll be things that you'll have to learn in the future of actually, there'll have to be other ways of determining whether that's a maximum or a minimum, because you can get curves that are going to change in different ways that say will have several maximum or minimum points on them. So what we're going to do first of all is we're going to differentiate this, and then, because if you think about the bottom here, minimum or a maximum point, it'll always have to have a slope of 0. So we're going to differentiate this, make it 0, and then find out what value of x. So you can actually see by the diagram it's going to be 2. We want to show how we could calculate that mathematically here. So we're going to take f dash of x, so the differential is equal to 2 by 3, so that's going to be 6x minus, drop the x, 12. And then get rid of the 6 at the end. So what we're going to do is take 6x minus 12 and make that equal to 0. So if you do that, pull the 12 over onto this side, you're going to get 6x is equal to 12. And then divide both sides by 6. So you're going to get x on its own, and then 6 into 12 is going to go twice. So you're going to get a value of x is equal to 2. So so it says what point in the curve. So we're actually not finished here, because we have our x value, but we also want to find our y value. You can see that's actually down here at minus 6. So just how to calculate that, you're just going to take f of x, just bracket this off so you can see it's a separate thing, f of x, and we're just going to replace that with 2, is equal to 3, I'll move this over a bit, 3 by 2 squared minus 12 times 2 plus 6. So you're going to get that equal to 2 squared is 3 by 4 minus 12 by 2, 24 plus 6. We can finish that all off then. It's just going to be equal to 4 by 12, or 4 by 3 is 12, 12 minus 24 plus 6. And you're going to get 12 minus 24 is minus 12, and then minus 12 plus 6 is going to be equal to minus 6. So we're going to get, in this case here, we're going to get y is equal to minus 6. And we can see, like I said earlier on, we can see by looking at our graph, but it's important that we knew how to actually figure that out, that is a minimum point. So meaning it's down on the lower part of the curve here. So that's everything on differentiating by rule and a couple of examples there. So thanks very much for watching.